Okay, good day everyone. So actually I need to re-record this explanation, so that's why you can see some mark already marked because due to some technical error, the previous video was unsuccessfully saved. So that is the thing need to record. So okay, so first question. Microcontroller pins is configured with internal pull-out resistor. A momentary switch is connected between this pin. So it don't mention anything, so there's big a microcontroller pin, so it can be any pin and also a ground. Okay, so that's mean you can imagine, and also in the module there's we call this one is sourcing. Okay, sourcing mode. You can see a sourcing mode. Sourcing mode that's mean one wire go to the pin and then go to the switch. Correct no? No, correct. No. Okay, so but you know that there is a VCC, no VCC, the pin and also the ground. So you can just imagine. So this is your microcontroller, and then the ground is other place. Okay, ground GSD. Okay, ground. So in between there is a momentary switch. So this is, let's say this is switch. Okay, so between that. So that's mean if you activate this switch, what is going to happen? So what happened to the pin? Okay, so definitely the pin will short to the ground. Okay, I think this is a very basic thing. Okay, so if you if so this is not so appropriate, but it's a very fast way to show you the thing. So let's say this is a switch. So when you press a switch, so if you short circuit, that means the circuit will be connected to the ground. So of course here this one, before that we need to put a resistor. Okay, there's a resistor here. Okay, so that when you press the thing, so if you know a short circuit, so but you don't need a resistor because there's a pull up resistor, meaning that internally you already put this pin go to the 5 volt or VCC. Okay, VCC. Okay, so there's a story for the question 1. So what happened if you using this code, okay, and then you read, okay, digital pin, okay, and then equal to high, then you take action. So what it means? Okay, so we read the first situation. The action is this one. Okay, action will never occur because the pin always low. Correct? No, it's no. Okay, because what you connect is a switch. Switch actually is a momentary switch. That means if you don't press, so if you open the circuit. Okay, so this one definitely is wrong. So action will occurs only when the button is pressed. So when you press, so what happened? So when you press the button, okay, this one is release. When you release, this means you not press the button. Okay, so what you're going to read? You read high, am I correct? Because there's no short to the ground. So you read high. Read high meaning that you go into action. So this condition is fulfilled. So that's why it's correct. Okay, so apparently the answer will be the B. So of course, as usual, we are not going to directly to give an answer. Okay, so what we're going to do is we will read the rest of the question and the selection. Okay, action occur only when the button is pressed. So when you press, it short to ground. So definitely it is not working. So the condition is not working. So the action occur continuously regardless the buttons that also inappropriate. So that's why the answer is B. Okay, so next is question 2. Analyze the following scenario. The sensor will provide 5 volt signal when either and 0 when is triggered. So that's means if you don't do anything, so you will receive 5 volt, but you will read 0 volt when it's triggered. So this is a sensor output. Okay, so which software configuration correctly identify trigger? So we want trigger is when we know that if you give us 0, so apparently the answer is C. Okay, sensor is active low. Okay, using this. Okay, sensor is active high using this. So what mean active high, active low, as you learn in chapter 2 as well. So when sensor is activated, so it will give you high or low. So apparently this sensor when you activate, so it will give you 0. So this is active low. Okay, so that's why you're going to using this condition in your software. Okay, number 3. This one is also very straightforward. Okay, number 3, evaluate the source code. Okay, why loop? Okay, so this question 3, evaluate source code. Okay, so given you this source code, even though in straight line, but you expected to understand. So while loop, so it's the second compulsory function of the Arduino. So we define this int integer, the variable b, the value, okay, bal equal to, we using this API digitalRead pin 7. Okay, and then why active high? So actually it's defined in the second sentence. So pin 7 is connected to a pull out switch. So this means if you pull up, the pin go to VCC, so it's a pull out. It's a pull out. Okay, this one is a pull out. So pull out meaning that when there's a pull down resistor, pull out switch, pull down resistor. So normally if you normally off, normally ground, so if you press, it will go to high. Okay, so you read this one, and then you're going to toggle the signal. So if this one high, you're going to read low. Okay, so the pin A is connected to LED sourcing. Okay, so that's why you maybe you detect some noise. As you can see, I written here, LED will switch on. Okay, will on when it's high because it's sourcing. Okay, sourcing, so it need to be high in order to on. So it's a active high, meaning that if I not press the switch, so it will not activate. If it activate, it's activate pull out resistor. So if you press, so it go to high. If you do not press, so it will go to low. So we see the first description. LED will turn off. Okay, when the switch is pressed. Okay, let's say we press, what we get high. With a pull out switch. We get high. If this high, we go and toggle the value go to low, so we digital right pin at low. So when low, LED will off. So the question, the selection A is correct. And selection A is correct. That D. If you see number D, LED turn on when the switch is pressed. Okay, actually same as the first one, correct? So one is turned on, one turn off. This one correct, this one is definitely wrong. Okay, it's C and B. B and C LED always off or on. Okay, regardless the switch, this one definitely is wrong. When we changing the switch for this source code, it's going to do something. Okay, we always off, also incorrect. So if we read this means if we are not pressed, okay, that is going to off or on. If we are not pressed, we will read low. Low toggle here will be high, so it will on. So logic is inverter. So this one also definitely wrong. Logic inverter is this toggle this symbol. So it's not due to this thing. So that's why the only answer it will be the A. Okay. Question 4. Okay, you are given this sensor. This is also is stated in our module. Okay, chapter 2. Okay, then we use this one to sense 25. This one you're going to be using the module to there's a plot there. You see the graph. Okay, see a graph. After that, you will find out that 25 degrees Celsius. Okay, so based on the module that I have is a 12 page 12. Need to be careful about the the type. Okay, so there are A, B, C, am I correct? So it's a TMP36. So this is the type B. Type B. So you read 25 volt. If you see the vertically, so you go up, you're going to see 0.7 something. So let's say 0.75 will be the voltage provided by the sensor. Okay, then you're going to using the next pages. formula. Okay, you substitute the value that you read. Okay, so it's a 0.75. So the V reference 5 volts, so you put the 5 volt here. So ADC is what we're going to get. We want to know what's ADC, and then the SIM bit is 10 bit. Okay, be careful if this is the ESP32, so it will be 12 bit. Okay, so 10 bit, the maximum will be the 1023. Okay, 1023. That you solve this equation, you're going to get the ADC approximate 153. Okay, so this answer for number 4. Okay, and then number 5, evaluate the following code snippet, snippet, digitalRead 9, and then we change or we toggle the signal we using digitalRead 9. So that's mean we're going to read this pin. So if the pin is on, so we're going to make it off. If off, we're going to make it on. Okay. So basically something for blinking for every 1 second. Okay, using a delay. So if LED is connected to pin 9 in sourcing mode, what is the resulting behavior? So we see at number 1, LED will stay on permanently. This one definitely wrong, because as you can see that we're going to read and then toggle the signal. So the B LED will only on. Okay, so that okay, when the pin is read as low, is only on. So don't know what actually is something parameter. So this one you can see I put a symbol. It's no very clear this answer is wrong or correct. So C, the LED toggle is set every second. Okay, correct, 0.5 hertz blink. So this one definitely is the right description. I think it's very straightforward.